32 or float 16 or whatever you want to do it. Okay. Now that is one way. The second method is the third method. In fact, this is third method is using the second method is using the data type itself is as a function over here. Data type itself, we can use it as a function. The third method is this one, as type. Okay, as type is a third one. Now these are the three methods you have to remember, guys. Okay. Now let's see one thing I was forgetting all the time. Like I said you, right? Okay, let's continue with this one. Okay. Now, if let's see the Numpy. Numpy work, whatever the Numpy is doing, you can do it with list. No doubt you can do it with the list. Both are there. Both are data structures. Both are data structures. But difference is Numpy will, I said you, what is the major difference? Occupy less memory. Numpy will occupy less memory. And Numpy is very fast in execution. Very, very fast. Okay. Now, Numpy is very flexible. Flexible over here. Okay. Clear, guys? Numpy is very flexible. Flexible means it is very convenient. These are the three important things because of which you will be going with the Numpy compared to that of list. And as this is the major nature of the Numpy, okay, the pandas is built on Numpy. As I told you, pandas is really very powerful, guys. Now it is really very powerful, and there is TensorFlow is there. This is also equally powerful. This is used for the deep learning. These two will use the Numpy as the base architecture. Based on Numpy, the pandas and TensorFlow is built. Now, once you know the Numpy, whatever we are learning it, these all are applicable over there. Now, what is the advantage of the Numpy is it will occupy less memory. Numpy is very fast in execution. Numpy is very flexible. That all will be applicable over here. Pandas will be very fast, very flexible, and very occupies less memory. TensorFlow is also same. Let's see that whether it really occupies the less memory or not. Now, in order to see a list, let's take a list. Now, I will give it as range of 1 to 10. What is this? What this will do? Huh? 1 to 9 values will be there over here. I am saying print B. What you are going to get it? You can see 1 to 9 values over there. Range of 1 to 10 it will give us. Okay, it will not give us anything like this. This is the way. Why it is? Why it is showing like this? It's generating the values. Is it generating the values? No. नहीं है क्या values? Generate हुआ या नहीं? अब होगा. For generate करेगा, range generate करेगा. कहाँ पर पढ़े? Python. No comments, please. Actually, ये generate कर रहा है. Actually, it is generating it, but this is not having the flexibility to show the values. This is not having the flexibility to show the values. So, in order to show the values, I will take the help of a list. List is what? A container. Now, if I do it, ठीक है, for loop कहीं पर भी नहीं है, फिर भी generate हो गया. क्यों? Range generate करता है, for loop नहीं. Range will generate the values. But range's nature is to generate the values. It is not having the flexibility to display it. That's why we are using the list over here. Okay. Clear, guys. Now, how much memory is occupied over here for this integer means there is something called as import OS or sys, I think so. Import sys. And under the sys, we are having get size of over here. Can you see this? The get size of. This function will tell us what is the size, whichever one you will get, what is the size it is occupying. Now I want the integer size. What is an integer? Tell me an example of integer. One example of integer. 10. Okay, 10 is an integer. Okay. Now what I'm doing is I'm getting the size of an integer. Okay, I'm getting a size of an integer. Now let me run it. How much is that? 28 bytes it will occupy. 28 bytes it will occupy. Okay, but this is a dynamic one, guys. This is a dynamic one. There's a lot of things will be there. If you go and give it the biggest value also, it will be taking it over there. Now let's take the numpy. Now, okay, this is occupying. This is integer is occupying 28 bytes. Okay. Now, how many numbers are there here? How many numbers are there here? 9. So 9 into 28 is a total number of value switches. Now, if I am doing it something like that, range of 1 to 10,000, how many values are generated? Okay, this is like 9,999 values. I will be putting in a variable called as num. Can I do this? It is generating. No doubt it is generating. So how many values it is generating? Total 9,999. I want to check it out that how much memory is occupied over here. How I will do it? Num is what? Total number of values, right? Total number of values. Or you can say it list of num also. If you have any doubt, you can take it list of this one. This will be having the total number of values. Okay. How to know that how many values are there inside this? Length. Length function, you use it and you will be getting total number of values. Okay. Now num into, that is 9,999, or let's take it from 0 itself. So we will have a round figure 10,000. Okay, total 10,000. Sorry for that. 10,000 into, I will say that sys dot get size of, right? Get size of any number I will take 10. Now this gives us what? How much memory is occupied by an integer. Now how many integers are there here? 10,000. Into 10,000 I am doing it. Let's see that how much is the memory. Sorry, what is that? It is doing. Why it is not multiplying? Sorry. Now this is the memory which is occupied. Okay. This is total 10,000. 10,000 into sys dot get size of into 10, that is 28. 2,80,000 memory is occupied. Bytes of memory is occupied for this 10,000. Now let's do the same thing with the array. How to generate the array? np dot arrange. Arrange is there. 0 to 10,000. What it will do? It will generate the array of 10,000 values. I will give it as array 1 or array num. I will give it. Okay. Now, how to see how many elements are there inside? How many values are there in the array? Dot size. This will give us the 10,000. Now, how to see, how to get the individual value size? Item size will give us the individual value. Now, I will multiply them. Ary num dot size into ary num dot item size. What is this? 40,000. This one, 2,80,000. See the difference. This one is occupying less memory. This one is occupying more memory. But same number of values. You see, same number of 10,000 values. So that is what it is says that, you know, NumPy occupy less memory compared to that of the list. Okay, compared to that of list. This is a list. What you are doing it list. Can you see it? List. Okay. Now that is the way it will be. You can show it. Now next one is just imagine, guys, over here. Now you have a vehicle over here. This is your one vehicle. Okay. This is your another vehicle. Okay. Now this has to travel 100 kilometers over here. And this has to travel 100 kilometers. In all the cases, both the vehicles are same. Both the vehicles are same. Now, this vehicle is having 2,80,000 bags. This vehicle is having 40,000 bags. They are perfect in all the cases. Which one reach first? Why? The same thing over here. Numpy is occupying only 40,000, whereas list is occupying how much? 28,000. So which one will run fast? Numpy will run fast. Okay, let's see that whether Numpy will run fast or not. I will take an array. Okay, let's do it with a list. List 1 is equals to list of range of 1 to 0 to 1 lakh. I will give it. What this will generate? What this will generate? How many values it will generate? 1 lakh values it will generate. Let me see the length of list 1. 1 lakh values generated. Good. Now let's do the list 2. List of range of, now if I will give it over here, length of list 2. When I do this, this will also generate 2 of them. Okay. I want to add this value, each and every value of list 1 with each and every value of list 2. Okay. That is, first value 0, 0 should be added. Then 1, 1 should be added. Then 2, 2 should be added. 3, 3 should be added. How I'll do it? How I'll do that? I want to do that. This is a list, right? Both of them are list. Yes, I will print it. Print length. How I'll add the 2 element by element of the list. Pura batao. How I'll do it? Now this is a list. And this is also a list. Okay, this I have to print it. Tell me guys. How I'll do it? There is a zip function is there. Yes, the zip. And other way, indexing. How you'll do the indexing? How will do the indexing? Tell me. I is equals to, from where you want to start the indexing? 0, right? Or you can say this something like this. For range of, for I in range of, how much it is? Length of list 1. Anything you can take it. Length of list 1 or any list 2, because both are same. This will generate what? Values from 0 to 1 lakh. That is the indexing. This I will do it. List 1 of I will do it. First time I will be 0. So list 1 of 0 means it will get the first value. This I will add it with list 2 of I, right? Both. This one is 0. First it is 0. List 1 of 0 is 0. List 2 of 0 is 0. I am both adding it. And I am putting in the third list. I will give it as a result. This is a third list. I am putting inside this. How I can put this value into the list? Append. This one I will put it in the list. Result dot append. That's it. This will be added up and that will be appended into the list. Okay, clear? Now this I want to know that how fast it is running. That is important, right? How fast it is running. How to do that? We are having a import time. I will do it. Import time. This has to be at the top, guys. Just manage it. Time dot time is equals to, this is, I will take it as S. Now this will give us the current time. What is the current time? It will give us. That is, before starting of the for loop, I am creating this one. I am getting the starting time. Then after completion of the for loop, I will take the end time. E is equals to time dot time. Okay. Now, what is the time taken will be calculated? This is the starting time. S is the starting time. E is the ending time. Now, how to calculate the time consumed by this for loop? E minus S. That is end time minus start time. Right? End time minus start time. This, it will be very much in a small, guys, very small portion of that. It will be in the microseconds or something. So to make it a bit bigger, visible to us, I will multiply it with 1000. Okay, I will multiply it. Now this is readable one. Now this I will print it. Time taken. Okay, time taken. That's it. Okay, now let me do this. How much time it will take it? 178. Now it's, you take it as a microseconds, nanoseconds, whatever it is, but I multiplied it is just to show you over here. If I don't multiply it over here, it will be in the fractions. Can you see this? So to avoid that, I'm showing you with the multiplication of 0. Got it, guys? 62. Now sometimes it will be more, sometimes it will be less, something like that. It is happening each and every time. Okay. Let me take this one also over here. Before the time I'm doing it, before the time calculation I'm doing it, list 1 and list 2 over here. So I'm first calculating this, then I'm adding them and putting in the result. I'm not displaying the result. It will take, a lot of space. I'm just taking the time, 76 seconds. Okay, 76 seconds. Now, the same thing, I want to do it with the Numpy. So this one is the one I will be doing it. Now I will give it as NP1 is the first array. NP dot A range between 0 to 1 lakh, right? I will give it directly 1 lakh over here. Shall we find the starting and ending time? Print it, you will get it. What is there? Rashekar, just print that one and you will be getting it. Just print it. This is the start time. You can print that one, and this is the end time. You can print it. That will be in the microseconds, Rashekar. You want to print it? So now you go. Got it? So that is again, it's showing in its own calculations. It will be like in microseconds or nanoseconds. It will be there. This is not the seconds. Don't think that this is the seconds. It is stupid. Okay. This is the difference. Can you see that? There is our own reading will be there. Now this one NP2 is equals to NP dot A range. Okay. Now this one I am calculating it. Okay. This one length is equals to, I will see that NP1 dot size. How much it will be? 1 lakh. NP2 dot size. How much it will be? 1 lakh. Okay. Now what I am going to do it is, I am going to add them. I am going to add it and put it. Now in this case, how we added up? We have added up element by element using the indexing, or we can use the zip function also. We can do it. Because zip function, again, it will take something more time. So that's why I didn't use it. So this is the fastest way of execution, directly generating the index and doing it. Now, here in the Numpy, no need of going with the for loop or no need of going with the zip function. Just do it NP1 plus NP2. That's it. When you do it NP1 plus NP2, this it will be adding up and it will be giving us in the third one. Okay, now I did it. Now, if you see the NP3 dot size, you will get the same 1 lakh only. And type of this is NP3, type of NP3 is nothing but it is a data number. Now let's see the time consumed for this performing of this. How I'll do it? Again, S1 is equals to time dot time. Okay. E1 is equals to time dot time over here. All I will be doing is SE1 minus S1. S1 over here. This I have to multiply it with 1000 to see the reading over there. Okay, so now let's do this one. I will execute it. See this one. This one is how much it is taking? 58. Okay, now that is a microseconds or whatever it is. Now it's taking it as 80 now. Now when I come down over here and when I execute it, it's saying 0. Now it is saying 1.00. Each and every time it is varying it a bit. Now this time again it's taking the 0. It is saying 1.37. Now better is to this one to get it into this. This is an important one. You keep it over here. Okay. Now you see this. Okay. Now see the difference over here. It is taking 80 and it is not even taking 1 over here. So that is the fastness of the NumPy. And this on this NumPy, you will be dealing with the pandas. That is the reason why pandas is very successful, because it is very, very fast. Okay. Now, one more thing is that it is very flexible. I said it right, flexible. See that here, I want to add to list. What I have to do, I have to first generate the index and then get the element by element and then add it and put it over here, right? But whereas this one, you see, just add it. So here the operations, all the complexity is being cut off in the NumPy. All the complexity is being cut off. Okay, it's very, very easy. That's the reason why these three will be working very effectively. Whatever I showed you over here, these are the three things. We are on the same page. So NumPy is occupies less memory and very fast in execution and very flexible. So that is the advantage of that. Now let's move on to the next one. So the next important thing is like broadcasting rules. I want to do it. Okay. Now, what is this broadcasting? So, whenever you are performing some operations with the arithmetic operations with the NumPy, there are some rules you have to follow. These rules are applicable. This looks like very complicated if you don't understand. So, let me show you a small thing, guys. If I have an array, let's take an array. Now, I will take it as A1 is my array. Okay. Now, I'm creating a range between 1 to 10. So what will happen? It will generate a one-dimension array from 1 to 9. A1 over here. Okay. Now, or let me take it 1 to 4, 6 over here. Let me do it. Okay. 1 to 6. Clear? 1 to 5 we got it. Now, B1 I will take it. The B1. NP dot A range. 1 to 6 again I will give it 1 to 6 or 11 to 16 I will give it 11 to 16. Okay. Now I will run it. B1 is equals to I1. Now can I do it A1 plus B1? Yeah, I can do it. Now let's do the C1 is equals to NP dot A range. Okay. Now I will give it as 21 to 26, 20 or maybe like 5 to 12. I will 5 to 12 and I will run it. C1 is equals to 5 to 12. Now I want to do it A1 plus C1. Then no. Why? Huh? Size is different. Number of elements is different. Okay. The operand could not broadcast together when the shape is equals to 5 and 7. That is the difference. They both are different. Okay, good. Now, what is this value? I said it. This is a one dimension array, right? One dimension array is called as vector. When the two dimension array is there, that is called as Babu, Livama. Good morning, Antuna. Scalar vector okay, this is a matrix. Okay, when you do the two dimension, that is called as a matrix. Now, when there is a single value is there, scalar, it is called as a scalar. Now, scalar is 1, right? Only 1. Now, A1 is having how many? 5. Can I add them? Yes, you can. How it is possible? Now, when this is possible, why not this one is possible then? This one is 5, this one is 7. Why not this one is possible and why this one is possible? This is 1. Now, what this is happening is, this is expanded as per the size of this one. Now, this will be something like this. Here, this is a size, right? I will take this as a size. Okay. I will go to this one and I will take it as this as a size. Okay, this is a size. How much is a size? 5, right? So when we are doing with 5 elements with 5, I'm adding with 5 over here. This is what happening is, it is broadcasting. Broadcasting means it is expanding. Something like this. It is expanding like this. So this one is added up with this one. That is, if you take it, 6 is added with 5, 7, like this, it is added. This broadcasting is being done. But when we are having the 5 numbers, 6, 7, 8, 9, 10, and we are having like 5, 6, 7, 8, 9, 10, 11 and 11 or something like that. Now this is 5, this is 7. Why can't this will happen the broadcasting? So there are some rules will be there for this. Now there will be a lot of scenarios will be there. I will be showing you. Now let's take it that 2 by 2 array, guys. Now np dot a range. I want the array in the shape of like, okay, let me do it like np dot random dot rand int. I will give it the values from 1 to 10. And I want the 2 by 2 array. 2 by 2 array I want it. Now this I will give it as A2 over here. And B2 is equals to, again I will give it np dot random dot rand int. Here I will give it as 1 to 10. Here I will give it 2 by 2 again. Okay, both are same size. Comma is missing. And also ending is missing. Okay, now let's see the shape, guys. Shape and the size and the dimension, all of them. First, I will print A2. Now this I'm doing it because it's very important. A2. Okay. Now print A2's shape. How will you get the shape? A2 dot shape. Now I will get the print A2 of dimension. that is A2 dot end. Now let's do this. This is the actual array. Now you can remove this one if you wanted. It's going beyond this shape. Now you see, this is the array. Now this is the shape and this is the dimension. Now I will do it with the B2. This is the B2 and this one is B2 and this one is B2 and here B2 shape and B2. Now let's do this. Okay. Now I want to do the arithmetic operations. What is that? A2 plus B2. Now remember this one. The shape is same and dimension is same. Can you see this? Dimension is same and shape is also same. So what you are going to do? A2 plus. Now it will work? Yes. It will work. Now let's take a 3-dimension array. A3, if it is a shape is same and dimension is same, A3 is equals to np.random.randint. I will take it again 1 to 20 and I wanted the shape as 2, 3, 4. Okay, let's do it. B2 is equals to np.random.randint. Again 10 to 20. I will give it 2, 3, 4. Okay. Now I will run it. So what is the problem again? Comma. Okay. Let me add them. A3, B3. Let me add them, guys. A3 plus B3. Let me print the A3 and let me print the B3. These are the two. I want to add them. How I'll do it? A3 plus B3. Now will it add? Yes, no problem. Because shape is same and dimension is same. So when the shape is same, dimension is same, there is no problem at all. If it is 1 dimension, 2 dimension, 3 dimension, you can add it. No problem. Let's take it now. The first scenario is what over here is case 1. I will write it. Oh, okay. I will write it as case 1. One is, what will be the case 1? When the shape is same and dimension is same. When the shape is same and dimension is same, you can perform all the operations. Now, when I'm saying it, it is an arithmetic operations. All the arithmetic operations are possible over here. If you want to do anything, you can do it. A3 minus B3. Can you do it? A3 into B3. No problem at all. Okay. Now, when the shape and the dimension is same, then there is no problem at all. All the operations are possible. Now, let's do the second scenario, guys. What is the second scenario is when the dimension is same. Okay. I'm going to give it as case 2. Dimension is same and shape is different. Will it be possible? Will it be possible or not? Huh? Now let's take it A3. Okay, A3 we will take it. This is a 1. Now A2. This is a 1. Okay, let me do it something like this. A2 now I have to make it. రాజశేఖర్ రెడ్డి కదా తెలుగు కదా ఓ ఫోటో పంపి అమ్మా మెయిల్ ఐడి now A2 is there. Now A2 is this one. Okay, let me make it all together new one. A np2 or a array2 I will take it. Array2 I will make it as np.random.randint. I am taking it 100 plus 30 I wanted and the shape is equals to 3, 4. Can I do this? Can I do this? 3, 4 ARY2 is this one. ARY2 dot shape is equals to 3, 4 ARY2 dot dimension. 2 dimension. Okay. Now ARY like NP2 I will take it. NP2 numpy 2. np.random.randint. Okay. Now here I will give it as 10 to 30. Again, the shape is equals to 4,3. Can I do this? Yes. NP2 is this one. NP2 dot shape is equals to this one. NP2 dot ndim is equals to 2. Now see this, guys. Dimension is what? 2. Here what is the dimension? 2. What is the shape? 3, 4, 3. Here 3. Both are different. Dimension is same, different. Now that is what the second scenario I said. Dimension is same, the shape is different. In this case, now let me do this. NP2 plus ARY2. It's an error. It's giving us an error. Right? See, broadcasting is not possible over here. Now, next one, let me take it one more scenario over here. Now, like NP2, I will take it. This is that we have it, NP2. Now, what is the shape of NP2? 4, 3, right? 4, 3. Now, what is the dimension? 1 dimension, right? 2 dimension, sorry, 2 dimension. Now, I will take another one. Now, like AJ2, I will take it. AJ2. Okay. Now, this is another array. np.random.randint. And I will take it as 10, 30 and 4, 1. Okay, now I will do it AJ2 over here or AJ2.ndim. ndim. What is this? 2 dimension. NP2, 2 dimension. Okay. Now let's shape 4, 1. Okay. 4, 3, 4, 1. Now let me, this also comes in this category only. This category. Dimension is same, shape is different. Now NP2 plus AJ2, it is working. Previous case, dimension was same, shape was different, it was not working. That when it was ARY2 plus NP2, it is giving me an error. Now when I am doing this one, NP2 plus AJ2, it is working for me. See this, some cases it is working, some cases it is not working. The same thing happens with the third dimension also, 3 dimension also if you take it. The same thing happens over there. So why it is working in this case and why it is not working in this case? Okay. So whenever you are in this, so that is when the dimension is same and shape is different, guys. When the dimension is same and shape is different, first step, what you have to do it is compare the step 1. Okay. Compare shapes of the arrays based on the axis. I told you what is an axis, right? What is an axis? Now here, okay, sorry. If I am giving it as 4, 5. What is the axis of 4? What is the axis of 5? Now, if there is something like this, 2, 4, 6. What is the axis of 6? 2. What is the axis of 2? 0, right? Now, based on the axis, you have to compare them. Based on the axis. What is the shape we have done it, guys, over here? Let's take it 4, 3. That is 4, 3. Okay, let me write it down. Now, this is the shape, guys. NP2, I will take it. NP2 shape is 4, 3. That means this 4 is equals to rows, 3 is equals to columns, right? Now, let's take it AJ2. What is the shape? 4, 1. 4, 1. Now, what is the axis of this one? 0. What is the axis of this one? 1. What is the axis of this one? based on the axis, compare the shapes. Compare the shapes of the arrays based on the axis. Now this is the axis. 0 axis. What is this one? 1 axis. Clear? Now when you compare them, when the dimension is same and the shape is different, and when you compare them based on the axis, either they should be same or any of them should be 1. What is that? Either they should be same means when you compare both of them, both should be same. Is they are same? Yes or no? It's 4 and 4 based on the axis. 4 and 4. Is it same? Yes, this condition is correct. Or in this case, both are same? No. Any of them is 1? One of them is 1, right? Then it is possible. Okay, then it is possible. Otherwise, it is not possible. Let's take the another scenario over here. Now we are having NP2. NP2 shape is 4, 3, right? That's what we did it. Now ARY2 shape means 3, 4. Okay. Now based on the axis, this is the axis 0. These two will be coming on 0. And these two will be coming on 1 axis, right? Now what is the condition? Either they should be same or any of them should be 1, right? In this, both are same. Any of them is 1? No. So it is not possible. No need of going to the next one also. But still, if you want to go this one. What will happen over here? Both are same? No. Any of them is 1? No. So it will not. Clear? This is the. So when you compare, okay, when we compare the shapes of the array based on the axis, then either they should be same based on axis. Again, I will write it in the on axis basis, axis base, or any of them should be 1. Any of them should be 1 over there. This is the important point, guys. Is it clear? Any doubts? Do you want me to explain it again? Anyone? Okay, we'll do one more example, not to worry about. There will be a lot of like confusion will be there, guys. Just follow this, you should be getting it. Just follow this. First, if the dimension and the shape is same, no need to worry about it. You can perform all of them. When the dimension is same and the shape is different, that is a one scenario. Then you have to compare them shapes of the array based on the axis. When you compare, either they should be same or any of them should be 1. Now this is applicable for the 2-dimension, 3-dimension, 4-dimension, anything. Now let's do it one more example over here. Then you will get a clarity on this. Let me take it a 3-dimension array. We are already having a 3-dimension ARY, or let's do it something ARY3. It's not defined, but we will define it. Guys, if you want to get an empty cell above this one, this whatever I am highlighting, right? This one I want to get it above that empty cell. Then click on this part near the in. Click on this and put it A. When you put it A, you will be getting it above that. Now, if you want it below, click on this. Use the B. Automatically, you will get a value below. Now, if you want to delete it, double D. Now not over here. Here, click on this and say double D. That will be deleted. Again, once it is deleted, gone. Okay. Now let's do it over here. ARY3 is equals to, I want to make it np.random.randint. Okay. Inside this, I will keep it like values from 100 to 200. And shape is equals to 2, 4, 6. Okay? 2, 4, 6. Okay. Now let me run this one. ARY3. Okay. This is the one. Now let's do it the next one. NP3, I will take it. NP3 is also okay. NP3 is there. Okay, not a problem. NP3, I'm going to replace it. NP3 is equals to, or AJ3, we'll take it as AJ3, is equals to np.random.randint. And here I will use the same 100 to 200, and I will use it the shape as 2, 1, 6. 6 over here. Let me do this and let me see this. It looks like 2, 1, 3. What is this? This is AJ3. Okay, this is the one. Okay, this is the one. This one I want to add. Now let's see the shape over here. ARY3 dot shape, and okay, I will print it over here directly. AJ3 dot shape. When you do this, you will get it. Now let's do it on the axis 0. Okay, we will be comparing with the axis zeros, right? Axis 0. Both are same? Yes, both are same. Next come, both are same? No, they are not same. So any of them should be 1. Yes, this one is 1. Now in this case, same, right? Is it possible? Yes, it is possible. ARY3 plus AJ3 is possible. Got it, guys? Clear? Now let's take it one more over here. NP A3 is there. Huh? Yeah, A3 is there. Now A3 shape is 2, 3, 4, and ARY3 dot shape is equals to 2, 4, 6. Now compare them based on the axis. 0th axis is 2 and 2. Both are same? Yes. One axis 3 and 4. Both are same? Or any one of them is 1? No. 4 and 6? No. Not same nor 1. So you can't perform it. Got it, guys? This is the case. This is the way you will be facing the problem over there. Now,
Recording
how
in
many
progress.
dimensions it is trailing? How many dimensions it is less? 2 dimensions. So add 2 ones in front of this. So how much it will become? 4 dimension. What this one? 4 dimension. Now compare. First one, 0th index. Both are same? No. Is any of them is 1? Yes, 1. Because now when this one is 4 and when this one is 4, the dimensions is same. Okay, shape is different. Shape is different. This is the second case. This comes once I am equalizing the dimensions, automatically it will fall in the second case. What is the second case over here? This is the one is the second case. Okay, so I am getting this one, but I am adding one and making the equal dimensions. Automatically it will come into the second category. In this, what is there? Either they should be same or any of them should be 1. That is what I'm checking it over here. Can you see it? Is that same? No. Any of them is 1? Yes. Second case, 3 and 1. Is that same? No. Any of them is 1? Yes. This case, both are same. This case, both are different, but any of one is 1. So it is possible. So it is possible. Okay, guys? Now let me take it at one more example. Now ARY 2, ARY 4 we will take it. This is the one. We got it. Now let me take it the ARY 3 shape. Now ARY 4 dot shape. Will it be possible? No. No, it is not possible. ARY 3 plus ARY 4, it cannot broadcast this. Why? Again, the same things will be coming into the picture. First one is 2, 3, 4 and 6. What is the dimension? 4 dim. Next one is 2, 4, 6. What is the dimension? How many dimensions it is trailing with? How many dimensions it is less? 1. So add 1 over here. Okay. How many dimensions? The lower dimension one is how many dimensions difference is there? Add that many ones. Now this one becomes 4 dimension. This one becomes 4 dimension. Dimensions are same. Shape is different. So this will come under the case 2. Case 2. So in the case 2, we have to compare it with the based on the index over here, like this, axis, sorry. Based on the axis, we have to compare it. Let's compare it. Both of them are same? No. Any one of them is 1? Yes, this is okay. This one, both are same? No. Any one of them is 1? No. So this is not work. So then it will not work, but still, both of them are same? Yes. Both of them are same? Yes. These 3 are okay with the rules. This one is not okay with the rules, so you can't perform. Okay, guys? Clear? This is what is called as broadcasting rules. Okay? Clear? This is what is called as broadcasting rules. Any questions, guys, over here? Dev. Step 1. Shape. Now, both the shapes are different, right? Compare the dimension and add 1 to the trailing dimension. Trailing dimensions. How many dimensions it is trail? Add 1 to the trailing dimensions. Based on the number of dimensions it is being trailed with. Less. Okay. Then after doing this first step, the second step will be this one will be the second step. Okay, guys. Now this will work for you in all the cases. All the cases, whatever you take it, it will work for you. Again, I'm saying it, there will be a slight different way of explanation will be there in the different sources. Don't get confused. They will be doing a lot of different things. They will be doing it to analyze the things. But I feel that this is an easy and the best way to, first you know that there will be a 3 different scenarios will be there. One, the shape is same, dimension is same. Second one is dimension is same and the shape is different. And third one is dimension is different and the shape is different. This is the one. Okay. I'm continuing with the same one. I didn't do a new one over here. Numpy 2 only I will be doing it like this. This is the one. Okay, let me do some more functions so that it is easy for us. There are some built-in functions are there in order to perform the addition, multiplication and division. You are having the built-in functions. Finished? Once you finish, just let me know. I think that we are preparing the notes for you, material for you. Yeah? What is that? Like, you want material or what? वो ले लो ना बस काफी है कौन प्रिपेयर करे तो क्या फर्क पड़ रहा है Not me, don't involve me, they will do it after finishing of them. Now when it will finish I don't know because they send it to me, so there's other people also reviewing. I said it's okay. Huh? What? Don't expect all the things, guys. Again, I'm saying it. That is a generic material. Generic material matlab, like, you know, everyone will follow that. That's the minimum standards they will follow. Now, usse zyada do bhi mil raha hai to just take it. Don't shout anywhere. Okay, otherwise I have to follow that one. It's up to you. I'm saying very clearly that will create a lot of problems. I asked you, some of you shifted from there. Will that be a problem? That is creating a problem to me. Okay, guys. Now let's let's go with some functions over here. Okay, you can perform the addition. There is an add function will be there, guys. np.add. Add function is there. It will add 2 arrays together. Now it will take the 2 arrays and it will add it. This is like np.add. Add function. This will get you the 2. You have to give the 2 arrays over here. See this. This is the first array. This is the second array. Guys, again, I will say it, strongly recommend you get addicted to this. This one is the best way. If you face any problem, go through this. Everything will be there over here. Get addicted. No problem about that, because this will be always there with you. Always, every given single point or every point you are working on, this help will be there with you. How you have to do it? Let's just see this again. First, if you want to see what are the functions are there, dot and tab. you will be getting all the functions. No, I want to get this function. Okay. Now see, you are doing multiple things. It's not one particular. You have done the Python, you have done the SQL. Now you are going to do the statistics, Numpy, pandas, and TensorFlow. Everything remembering is not possible. To be frankly, it is not possible at all. Okay. So the best way is getting used to how to use the help, not the Google. Never do with the Google. This one is the best one. Yeah. If there is something we are not getting over here, if you want to go to the Google List, go, no problem. But this is the best way to do it. So if you want to do it, Shift and Tab, you will get the here, and then click on this. You will be getting the complete help. Now still you want to see the bigger help, just click on this up arrow. You will be getting it completely over here. You can literally, you will have complete the material over here if you start collecting all these things. But this will always be there. No need to worry about. So this is the way it is. Like you see, it is very clearly saying that x1, x2 is an array like here. This is taking the two arrays. Add two arrays, something like this. So it is giving us, if you are giving this one and this one or arrays, it is creating one array and this is the creating another array. Yeah. So like this, you can do it. Okay. Now I will give it as, now here we are having an array. Sorry, it is too small. ARY2 is there and ARY4 is there. Is this possible? ARY2 dot shape, ARY4 dot shape. Okay. Now this, is it possible, guys? Quickly. Yes, you should be saying that yes, it is possible. Okay. Now np dot add ARY2 comma ARY4. Is it possible? This is the one. Now there is something called as subtraction also. np dot subtract. Now this is the one. Now I will give it as ARY2 comma ARY4. Yes, it is possible, the subtraction. Can you see this? Now ARY multiply is there. Sorry, np dot multiply. And here you can give it as ARY2 comma ARY4. Yes, it is possible. Got it? Now this multiplication means what multiplication is? Element by element multiplication. This is an element by element multiplication. There is one more multiplication is there. What is that? Array multiplication is there. That is called as matrix multiplication. What is a matrix multiplication? Yes? Huh? Rows and columns, yes, just matrix multiplication. That's right, what you said. గోలీ వేసినావా నిజం చెప్తున్నావా తెలుస్తలేదు కదా, అందు గురించి అని టెన్షన్కి వస్తున్నాను. నాకు అదే కావాలి మరి ఎందుకు కాన్ఫిడెన్స్ ఉంటే. నౌ దిస్ వన్, see this guys, this is called as row into column. Row into column. If you take it, copy చేసాం. Okay, now let me see this one. See, it will take it first row of the, this is a array A, this is a array B, guys. Okay, this is called as matrix multiplication. First row into first column, first row into first column, then 1 into 10, that's what it is, 1 into 10, 2 into 20, then 3 into 30, and add them all. First one is 1 into 10 plus 2 into 20, 3 into 30. Now this one is again this 1 into 11 plus 2 into 21 plus 3 into, that is first row, first column, first row, second column. Okay, you have to do it. Then second row, first column, second row, and second column. This is the way you have to do it. This is called as matrix multiplication. There is one more is there, that is called as matrix multiplication. But in this case, we are not doing the matrix multiplication, guys. What we are doing is element by element multiplication. That is, first element is multiplied by the second element. Now you see, let me take a small array like x is equals to np dot array of, I will take it like 10, 20, 10, 20, and next one is 30, 40. I will get, this is one array, 2-dimension array. This is the 2-dimension. Now let me take the one more array, np dot range or array. Inside this, comma, this one I will give it as 2, 2, and this one is also 2, 2. Just to make it a bit clear, or 3, 3 and 3 and 4, 3 and 3 I will give it. Now let me do this one, y, x plus x into y. X into y is what it will do? 10 into 2 it will do it, element by element. 10 into 2, 20 into 2, 30 into 3, 40 into, this is what will happen. Got it, guys? Now, if you want to perform that matrix multiplication, that is called as dot operation. That is x dot of y. This is, now this is the matrix multiplication. X dot and dot dot of next array. That is what you have to do it over here. Don't get confused over here. Multiplication means the element by element. If you want to perform the matrix multiplication, x dot 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 of y. Remember that. So like this, you have all the built-in functions, guys. You have the division, you have the modulus, all these things are there. You can try it out over there. Now there is an important function is there called as, we will take some more time. Okay, chance ఉండదు 9 తారీఖు నుంచి ఛాన్స్ ఉండదు 11 కాగానే గంట కొట్టగానే పోతూనే ఉండాలి. From 9 there is a one more batch is there at 11 o'clock. So as soon as 11 happens, you have to go. That is the reason why I'm taking an extra time now. Okay, now let's take it like a one more important. There are some very important functions are there. One is a where function, and another one is reshape function. Reshape, where, and transpose, swap acts, and all these are some of the very important manipulation functions which can change the shape of the array. To change the shape of the array, we are having like, now I will write it this, guys. I will write it over here. Where is that picture? Here I will write the function, how to write it. Array 1, okay, array 1 dot dot of array 2. Just make a note of this one when you want to do the matrix multiplication. Okay, now let's do some simple things. That is a reshape function. Reshape function is, now there is reshape is there, resize is there, and there is transpose function is there, and swap axis function is there. Okay, axis or axis. Let me see the spelling. That is one. Swap axis. Now reshape function will be reshaping the array into our desired shape. reshaping the existing array into our desired shape. But the condition is the before reshaping, the product of the shape, that is the multiplication of the shape, should be equal to the after reshaping the multiplication of the shape. That in other words, like this, you can reshape it. You can reshape it. The after reshaping, the multiplication of the shape, what is the shape will consist of rows and columns. If you do the product of the shape, that should be equal to the size of the array. In other words, size of the array. For example, if you're having an array is shape is equals to, initially shape is equals to, that is like 3, 5. What is the size of this array? What's the size of this array? 15. Shape is 3, 5, right? Shape is 3, 5. What is the size? 15. Okay. Now what I am going to do, I want to reshape it. When I want to reshape it, ARY1 dot reshape, I will use it something like this. This is the existing array dot reshape. Inside this, give the shape. When you give the shape, remember that the product of the new shape should be equal to 15. It should not be more than that. It should be equal to 15. So, what are the possible things I can do it to get the 15? 5, 3. This is the only thing we can do it. Okay? Okay? Now, next one is, let's take another array, guys. NP1. So that's correct. What is said is correct. 15, 1 is also possible. That can also be given as 15, 1. So it is nothing but one dimension array. Okay. Now this shape is equals to, just take it as 4, 6, guys. How many? What is the size? 24. Okay. Now what are the possible reshapes we can do it? NP1 dot reshape. First one is, tell me, guys. 6, 4. Good. Next one. 2, 6. You can do this? Yes, you can do this. No problem. Whatever the dimension, it's least bothered. The product of the shape should be equal to 24. That's it. That you have to make it. Now you can do it one more also. What is that? 2, 2, 2, 2. 3. Okay, 3. Okay, like this you can do it. 4. It's whatever the dimension, you can play with it. Or you can give it as 4, 2, 3. You can do whatever you want it. But make sure that the sum of this one, the product of this one should be equal to the size of the array. Now let me do it. Ask. Want to write it, right? No, write it, no problem. ఉండు కొంచెం దమ్ము చేస్తుండు కొంచెం ఒక్కసారి. అంటే నంపై నువ్వు వాడవు, ఎక్కడ వాడవు నంపై? ఇప్పుడు నువ్వు సైకిల్ నేర్చుకుంటున్నావు, బండి నేర్చుకోవాలని సైకిల్ నేర్చుకుంటున్నావు అంటే ఏం రిలేషన్షిప్? సైకిల్ నేర్చుకుంటే బండి ఈజీ కదా, ఇక్కడ బ్యాలెన్స్ తెలుస్తుంది. ద సేమ్ వే Numpy is, you will not use Numpy anywhere. Very little you will use it. Very little. But when you know Numpy, the pandas will be very easy. Very easy to understand the things. EDA process అవసరం లేదు, నీకు పాండాస్ లోనే చేస్తావు నువ్వు అన్ని. నాకు నేను EDA process లో ఏవేవి అంటున్నావు నువ్వు, అవన్నీ నేను పాండాస్ లో చెప్పించేస్తాను. ఎందుకంటే EDA can be done in two ways. One is with the sklearn activities ఉంటాయి, దాంతో చేయొచ్చు. We can do it with the sklearn, but we can do it with the pandas also. So I want to complete the EDA process with pandas, and then when we go back over there, you will be having the sklearn mechanism also with you. So you will have both of them with you. So usually the pandas touch here in Gade, it is very complicated stuff. ఇది అయిపోగానే స్టార్ట్ చేస్తాం. ఇంకా 2-3 క్లాసులు అయిపోతుంది. అది సంపుతున్నాను కొంచెంసేపు బాగా, అది కంప్లీట్ చేసిన తర్వాత మాట్లాడుకుందాం. నువ్వు సంపకున్నాను. ఓకే, లెట్ మీ గివ్ ఇట్ లైక్ దిస్. NP N1 I will take it. np.random.randint. Okay, and I have something like 100 to 200, and the shape is equals to 4,6 guys. 4,6. Now np n1 is equals to this is the one. Now I want to reshape it. N1 dot reshape. Okay, there is a function called as reshape. Inside this you mention it like 6,4. Yes, you can do it 6,4. Okay, now why it is possible? Because the product of this one is equal to the number of elements of this. Number of elements is 26. np dot reshape 2,3,4. Now what is the current shape of this one now? What is the current shape of this array guys? N1 array. N1 array current shape 4,6 or 6,4? Latest ఏం చెప్పు నాకు. How many say 4,6? సైడ్కి రా స్వామి, నువ్వు అసలే 6 feet కనిపించవు నాకు. చెప్పు ఎందుకు? ఎట్లుంటే చేంజ్ చేసాం కదా ఇడా. చెప్పు ఎందుకు? What is said is correct, because this is not a permanent change. This is not affecting the array. This is only a view. This is only a view. It is not affecting the array. What they said is correct. Now you see this n1 dot shape is 4,6. This is only a view. It is not affecting the original array. If you want to affect the original array, you have to save it in this. Okay, this is the one you practice all the time guys. Now you see this, the shape will get changed to 6,4. Okay, this only view it is. Clear? Now n1 dot, I wanted to reshape it again. Reshape it to 2,2,6. Now what is the dimension? 3 dimension. Now will this be permanent? No, it will not be the permanent. If you want to make it permanent, now it will be a permanent. Okay, one you have to save it in this, then it will become a permanent one. Okay, now let's give it something like this. N1 dot 4,2,2. Sorry, reshape 4,2,4,4. Like this I want to do it. Can I do it? No. Cannot reshape the array 24. 24 is what? Size of the array into the shape 2,4,4. When you multiply it, what you are getting it? 32. Okay, this is what it is. Okay, I will stop it guys. He is just pinging me all the time. Guys, we will not have the class tomorrow because I have some appointments, so we will meet it on Monday.